Welcome to this detailed educational video on threading and synchronization in the JVM, a key topic for any senior Java developer. As you build scalable systems, understanding how the JVM handles threading and synchronization will enable you to write efficient, thread-safe code for modern applications. Java's threading model supports concurrent programming, which allows multiple threads to run simultaneously, sharing resources while maintaining consistency. The JVM manages threads through the operating system, and Java provides tools for creating, managing, and synchronizing these threads to ensure safe execution. Let's first explore thread management. In Java, threads are managed by the JVM in collaboration with the underlying operating system. The thread class in Java provides developers with the ability to control thread lifecycles, from creation to execution and termination. Creating and starting a thread is as simple as extending the thread class or implementing the RUNNABLE interface. The JVM schedules these threads and manages context switching based on the system's capabilities. Next, we'll dive into locks and monitors. Each object in Java has an intrinsic lock or monitor. A thread must acquire this monitor before it can enter a synchronized block of code. There are two types of locks. Intrinsic locks, or synchronized locks, are automatically associated with every object in Java. When a thread enters a synchronized method or block, it acquires the object's intrinsic lock. Explicit locks, such as lock and ReentrantLock, offer more flexibility. These locks need to be manually acquired and released, giving developers finer control over synchronization. However, synchronization can lead to a serious issue called deadlocks. A deadlock occurs when two or more threads are blocked forever, each waiting for the other to release a lock. For instance, if thread A holds lock 1 and waits for lock 2, while thread B holds lock 2 and waits for lock 1, both threads will be stuck indefinitely. As a senior developer, understanding how to detect and avoid deadlocks is crucial. You can use techniques like ordering locks or implementing timeouts to prevent this situation. Now, let's break down the different thread states in Java. A thread goes through several stages in its life cycle, and knowing these states will help you better manage thread behavior. New. A thread has been created but has not yet started. At this point, it hasn't entered the JVM's execution thread pool. Runnable. The thread is either actively executing or ready to execute. This is the state where the thread is running or waiting for a CPU resource to run. Blocked. A thread enters this state when it's waiting for a monitor lock to become available. This typically happens when multiple threads try to access a synchronized block or method. Waiting, timed, waiting. A thread is in this state when it's waiting for another thread to perform an action, such as releasing a lock or notifying it. In timed waiting, the thread is waiting with a specified timeout. Terminated. Once the thread completes its task and exits, it enters the terminated state, indicating that it has finished execution. To recap, thread management is handled by the JVM and the underlying OS, with Java providing tools through the thread class. Locks and monitors ensure thread-safe access to shared resources, but improper use can lead to deadlocks. Understanding the different thread states helps in managing thread behavior, optimizing resource use, and debugging. Mastering threading and synchronization is critical for writing scalable, concurrent Java applications. As a senior developer, you'll frequently encounter multi-threading challenges that require careful synchronization and awareness of thread states. Thank you for watching. Make sure to like, subscribe, and hit the notification bell for more advanced Java programming insights. Stay tuned for our next video on advanced thread synchronization techniques.